Alright, so we are doing boundary conditions in beams, and we're looking at the commonest ones, and we're looking at these four, right? One thing I should notice is that this is basically physics, and then you should be able to even look at them and then see what's actually happening. Another thing too is that the ones on the left are related, the ones on the right related for this particular four conditions, in particular for these ones, and then we are going to look at why it is so for them. So we start with the free end, the last one. So let's say there's a free end, right? And then let's say you apply a load here. What happens is that the beam goes something of this sort, this way. So move from its initial position to here. So we see there's a deflection, right? So there's the y, because the coordinate system is here. You see the deflection y is not 0, right? And since there's been a deflection, meaning that there's nothing resisting there's nothing preventing the beam from deflecting, right? So definitely there's a shear, right? So the beam has deflected, right? So meaning that there's a deflection. And since there's a deflection, meaning that there is no force that's preventing the beam from deflecting at that point, right? So definitely the shear there is 0, right? And then when I check here, this is the initial position of the beam, right? This. And now you apply a load and it moves down like this. When you compare this, you get some sort of triangle here. You see that there's a slope, right? So there's definitely a slope here. So the slope here is not 0. And since the slope here is not 0, so this slope here basically talks about rotation, right? So if the beam is able to rotate at that side, meaning there's nothing, right, preventing the beam from rotating at that end. So meaning at that particular moment there, the moment is what? 0, because the bending moment is what's preventing the beam from rotating. And we've seen clearly that there's actually a slope. And then we said initially that these two are related, so as these two are related. So that's the meaning for it. So we see how what values we get for the remaining other end conditions. Okay, so let's go by. I move on to the third one, fixed end. So fixed end is something like this. So you have a beam, the end here is fixed, right? Wherever it is you apply the load, even if you apply the load directly at the fixed end, what happens is that this particular beam, this fixed end here prevents the beam from moving left, right, prevent the beam from moving this way. There's no movement in that side, and there's no up and down movement, right? So definitely, since there's no up and down movement, we can clearly see that the deflection is what? 0, right? So deflection here is 0, right? And since deflection is 0, meaning that there's something, right, a force, a reaction that's preventing the deflection at that very point here. It's preventing deflection there. So definitely there's a force, and that shear force there is not 0. Are you okay? So move to the M and then the bending moment and the slope. At this particular point here, whatever it is that you do, even if you do magic, there's definitely not going to be. We are doing physics here. Sorry, I'm not doing magic. I'm sorry. This very end here, there's not going to be any bend. Even if this side bends like this, nothing will happen here, right? So meaning there's not going to be any rotation or what do you call it? Rotation here, right? And since there's no rotation here, you can see that the slope there is 0. Right, and since the slope is 0, meaning there's something that's preventing the beam from rotating at that end, right? So definitely the moment here is not 0. Okay, now move to the end roller condition. So let's see, roller is something of this sort. Let's see, something of this, and then we have this, and let's say the beam is somewhere here. What this one does is that it allows, because of these ones here, it allows the beam to move this direction is allowed, but up and down is not allowed, right? Definitely you can see that the deflection is 0. So that's for end roller. We are here now, right? So we can see that it doesn't allow deflection. The deflection here is 0. Since deflection here is 0, meaning there is something, a reactional force or something that's preventing the beam from deflecting at that point. So here it's not 0. Are you okay? Now look at the moment. Now for this particular one here, let's say you apply a force here. There's a force here. the worst case scenario, what happened is that because this one here doesn't allow up and down, the beam could turn slightly, something of this sort, turn a bit something like this, right, just slightly, but there won't be any up and down movement just at that point. But then when you look at it very well, you will see that some sort of bend at that side, right? See something else. So there's some sort of bend at that side. Take a triangle, see there's some sort of bend on that side. So definitely there's some bending, right? But there's no up and down movement. And since there's some bending, you can see that the slope here is what? Not zero. Okay. But there's some angle when you take a triangle from that side. And since the slope here is not zero, so meaning there's some bending, meaning the bending moment is what actually prevent bending, right? Meaning the bending moment here is definitely zero because there's nothing preventing the beam from bending at that side. Okay, the pin end is the same thing as the ruler end, but let's go over it. So we have a pin end, something of this sort, this way, right? There's no this one here, right? There's nothing like that, meaning that the beam, the support, the pinned end will not allow the beam to move sideways. So there's no sideways movement, right? And then again, there's no up and down movement. So clearly, because there's no up and down movement, you can say deflection is zero, right? For the pin end, deflection is zero. Because deflection is zero, meaning there's something, right? A force that's preventing the beam from moving up and down or deflecting this out. Right? So definitely the shear there is not zero. Let's got this, the slope, and then the other. Then again, the same thing. The worst case scenario, what will happen at that very point is that when there's a force here, there'll be some sort of bending, right? The beam. But just at that point there, right? Just at that point there, where you take something of this sort, some kind of triangle, and you check, compare the two, the initial and the final. So it's just like the, what do you call it, the ruler end, just the same thing. A triangle here and you compare, you see that there's actually some kind of bending, right? Since there's a bending, right? Since there's a bending, the slope here is not zero, and since the slope is not zero, mean that there's a bending, mean that the whatever that is that can prevent the bending is zero, and the bending moment is what prevents the moment is what prevent the bending. Right, so this one definitely is zero. That's it. All right.